The fastest main sequence ever identified in the Milky Way has been discovered by astronomers. A strange star named LP40-365 is hurtling toward the edge of our Milky Way galaxy at a speed of 3.2 million kilometers per hour. There are many planets, stars, and other celestial bodies in space, which puzzle scientists and can cast doubt on physical and astronomical rules. What space objects violate logic and go against everything that we know about the universe? Get ready to discover the effects of star feeding on other stars, where they come from, and how stars can survive after bursting. This and so much more in today's video, so make sure to watch till the very end. In today's video, we'll be talking about the strangest star, LP40-365, and the controversies around it. But before we start, make sure to give the video a thumbs up, make sure to subscribe, and hit that bell icon to stay connected. This star is not simply rotating along its orbit, but it is also an actual shooting star. It is traveling at a speed that would cause it to leave the galaxy. It was caused by a supernova that featured a white dwarf and another star orbiting each other quickly, potentially once every hour, and growing progressively more dangerously close until the final collision. A binary system requires gravity to remain intact, even when broken up. Pieces of both stars flew in opposite directions at a dizzying speed that had been orbiting due to the absence of gravity. Stars, especially extremely massive white dwarfs, frequently orbit one another in pairs. Supernovas, the greatest explosion in space, can occur in such binary systems if one white dwarf transfers too much mass to the other. This is because they are the most common type of astronomical object. Most of the time, it's difficult to tell which star was the giver and which one was the eater. However, because LP40-365 rotates slowly, the astronomers are convinced that the object is cosmic debris from the stellar explosion. The subsequent supernova certainly shot both stars out at a breakneck speed as they orbited each other at tremendous speeds, but we've only been able to spot one. These supernova survivors are even more fascinating because, in contrast to our Sun, which is mostly made of hydrogen and helium, they are metal-rich. Any element heavier than hydrogen and helium is regarded as a metal by astronomers. This cosmic fragment is very metallic. Along with other supernova survivors, this star has some of the highest metal levels ever discovered in the stars as a result of what they have been through. Nuclear processes are extremely powerful in exploding stars. A star that is still generating energy burns hydrogen, which undergoes nuclear fusion to create helium. Atomic nuclei can be smashed together to produce nuclear fusion, which can turn one element into another. Large amounts of energy are released along with various nuclei and subatomic particles. The large supernova explosion is caused by carbon atoms starting to fuse in some stars as they age. The temperatures reached in these explosions promote a variety of reactions, some of which produce heavy metals. The same thing that created LP40-365 also released enough heat and energy to produce enormous amounts of metals like nickel and iron. The hardcore metal star's modest rotational speed is another oddity. There is usually one star that ends up spitting material onto the other one, which gets too much star material inside of it and gets blasted apart. Because supernovas are typically hard to see, it can be difficult to determine which star was the giver and which one was the recipient. But LP40-365's sluggish rotation rate probably reveals something. Odelia Putterman, a research co-author and former Boston University student who has worked in Hermes' lab, said, "To have gone through the partial explosion and yet live is incredibly amazing and unique, and it's only in the last few years that we've started to consider this kind of star could exist." The strange star was discovered while survey data from NASA's Hubble Space Telescope and transitioning exoplanet survey satellite were being examined. The scientists discovered that LP40-365 is not only moving quickly, but also spinning once every 9 hours. According to astronomers, a piece of star shrapnel that was left over after a more massive star went catastrophically supernova. With such a massive kick from that explosion, LP40-365 was sent into interstellar space and is currently on course to completely depart the Milky Way after achieving the necessary velocity to do so. It's a hypervelocity star, a rare star that travels at a rapid speed of about 852 kilometers per second, or 529 miles. In addition, scientists have found that LP40-365 rotates, which provides a clue as to the explosion that created it. LP40-365 is currently only 0.14 times as massive as the Sun. To what extent it was a component of the original white dwarf in the binary or companion stars is unclear. The star's rotational speed can shed light on this. LP40-365 was most likely once a component of the white dwarf by completing calculations and utilizing estimated masses of it and its companion. It will depart the galactic sphere in around 5.3 million years because it is on an escape track. LP40-365 was probably previously a member of a binary containing a high-mass white dwarf, which was probably roughly 1.3 times as massive as the Sun. This is extremely close to the Shamar-Kashgar limit, which has a critical mass of roughly 1.4 times the mass of the Sun. If the white dwarf develops any more mass than this, it becomes unstable and typically explodes in a Type 1a supernova, which is famed for its stunning display. Many white dwarfs have binary companion stars, and LP40-365 appears to be one among them. Because there are so few known mechanisms that may create such fast stars, the velocity is evident. Additionally, the star's makeup is largely metallic. Because of the velocity, a supernova is the most plausible origin, as we know that supernova explosions produce heavy metals. It appears that LP40-365 was the receiver. Due to the inflammatory process present, both stars in a double supernova will enlarge, but the donor star will still grow less and rotate more quickly. This is due to the conservation of angular momentum, which states that an item will continue to spin at its current speed as long as no additional tension is applied. Spin speed is influenced by radius. When an item is moving in a straight line, angular momentum behaves in the same way as linear momentum. Astronomers observe both are included in the cannonball. Nobody knows what happened to the other star. It most likely also was punted away, but in a different direction. By now, it might be anywhere. But locating LP40-365 can help us learn more about these intense processes, how they generate heavy elements, and the characteristics of the stellar shrapnel they produce. If we get to know where the star is now, we will begin to understand what happened with many other comparable stars like LP40-365. These are extremely strange stars. In addition to being among the fastest stars that have ever been observed, stars like LP40-365 are also among the most metal-rich stars that have ever been found. Unlike stars like our Sun, which are primarily made of helium and hydrogen, stars that have experienced a supernova are primarily made of metals because what we're seeing are the byproducts of violent nuclear reactions that happen when a star blows itself up. This makes studying star shrapnel like this particularly fascinating, isn't it? Scientists are certain that LP40-365 is debris from the star that self-destructed after being fed too much mass by its partner when they were originally orbiting each other at high speeds. The explosion slingshot both stars, leaving only LP40-365 visible because the stars were orbiting each other so swiftly and tightly. LP40-365 may have more to tell us as it continues to hurtle toward the edge of our Milky Way about the unique type of star that it is. What are your thoughts about this strange star? Please share your views in the comment section below. We hope you liked today's video, and if you did like the video, please don't forget to subscribe and press that bell icon to stay notified when we release new content. We'll see you in a new video. Take care.